Okay, so get this. Today we're diving deep into esports strategy prediction. Like, imagine knowing where pro players will move before it even happens.
Yeah. Sounds kind of wild, right?
Totally. But that's exactly what some researchers have figured out how to do using AI. And you know what?
It's,
It's crazy accurate.
it really is. The study we're looking at today, they actually used machine vision and AI together to predict player positions in CSGO.
Counter-Strike, global offensive.
Yeah, CSGO.
For those who don't spend every waking moment glued to Twitch.
Exactly.
But even if you're not a hardcore gamer, you gotta admit, being able to predict where pro players will go in a game.
It's kind of mind-blowing.
Totally. So most people probably think of CSGO as just this, like, fast-paced shooter.
Right. Run again.
But what really makes it fascinating and what makes this research so groundbreaking is the strategic depth.
Absolutely. Pro CSGO teams, I mean, they spend hours studying opponents,
Yeah.
analyzing maps,
Mhm.
coordinating like every single movement.
And don't forget the in-game economy.
Oh yeah, that's huge. Money earned is tied to like what weapons you use for kills.
It's like chess, but with way more explosion.
Exactly. High stakes, high pressure.
So how do these researchers even begin to, like, capture all that strategic stuff?
Well, they started by recording tons of CSGO matches, hundreds of them, and they zeroed in on the mini-map.
That little overhead view, right?
Yeah, the one that shows the map layout and player locations. It's like turning the whole match into a like constantly changing chessboard.
Okay, I can see that. But I imagine that's a ton of data to process. Do they just, like, throw all of it at an AI and hope for the best?
Not quite. They were super strategic about how they collected that data. They only captured the minimap at a very specific moment. 1 minute and 45 seconds left on the clock.
Why that time?
Because that's typically when teams are executing their big strategies. So by focusing on this one moment, they could compare different matches, apples to apples. Then they use some really clever image processing techniques to basically isolate the players from the background of the minimap.
So it's like they were highlighting the players and removing all the clutter.
Exactly. And the result, they call them player position stencils.
Player position stencils. Okay, I kind of like that. It's like a snapshot.
It is. It's a snapshot of, where everyone is at that crucial moment.
But it's not just a random snapshot, right? It's carefully chosen to capture the strategy. But player positions, that's only one part of the picture. You also need, like, the context. What's happening in the round, who has what weapons, things like that.
You're totally right. So they combined these position stencils with what they called miscellaneous round information.
Miscellaneous round information.
Yeah. Basically, they captured a bunch of other details too.
Yeah.
Stuff like which team won the previous round, what weapons each player had, if the bomb was planted, things like that.
So they weren't just looking at where players were, they were trying to understand why they were there.
Exactly. The decisions that led to those positions. It's all connected.
So it's like they created a full picture of the game at that one specific moment, like a freeze frame, but with tons of extra data attached. Okay, this is where I get a little lost. How does an AI actually learn from this kind of stuff?
That's where the artificial neural networks, or ANNs, come in.
ANNs, right.
Think of them like a network of interconnected neurons, right? Kind of like a simplified model of our brains. They process information, learn from data.
So they basically taught a computer to think like a pro CSGO player.
In a way, yeah. They trained separate ANNs for each round of the game.
The separate ones.
Yeah, because each round is different strategically. They use this training algorithm called Bayesian regularization. It's a bit more complex, but it's better for small and noisy data sets, like game data.
So not just one big AI brain, it's like a whole team of AI specialists.
That's a great way to put it.
Okay, but all this fancy tech, did it actually work? Like, could they really predict where players would be?
That's the amazing part. They tested the whole system on 5 matches the AI had never seen before.
Like a real test.
Yeah. For round 2 predictions, the accuracy was around 67%.
67%.
Not bad.
But it gets way better. For later rounds, the accuracy jumped to well over 95%.
95.
Yeah.
Seriously.
Yep.
So this AI can basically tell you with near certainty where pro players will be minutes into a match.
Pretty much. It's pretty wild, right?
That's insane. What does that kind of accuracy mean for, like, actual teams? Could they use this to get an advantage?
Oh, absolutely. Imagine a team knowing in advance where their opponents are going to be. They could plan their strategies, their counterattacks, everything.
It would be like having a cheat code for strategy.
Kind of, yeah. But it also brings up a lot of questions about, fairness in competitive gaming. What's ethical, what's not?
Right, because if everyone had access to this kind of tech,
It would completely change the game.
it makes you think about the future of esports, for sure.
It does.
Okay, but before we go full on philosophical, I want to get into the nuts and bolts of how they built this thing. How do you go from like raw gameplay footage to something an AI can actually make sense of? It's a pretty amazing process, honestly. They had to use a lot of different techniques.
Lead the way. I'm ready to geek out on the technical details.
All right, let's start with machine vision. The goal was to, get those player position stencils from the minimap. But raw video, that's just a bunch of pixels. They had to teach the computer how to actually see those pixels as meaningful information.
So how'd they do that?
A whole series of image processing steps. First, making sure the AI was looking at the right part of the screen, the minimap. Then they had to figure out how to separate the players from the background of the map.
It's like teaching a computer to see the players as, like, separate objects.
That's a great way to put it. They used a technique called color thresholding. It's like setting up a filter that only lets through the colors of the player icons. Everything else gets blocked out.
Kind of like a digital sieve.
Exactly. Filtering out the noise.
Ah,
But it gets even more complex. They also use things called morphological operations.
morphological operations. Now we're getting fancy.
Yeah, this is where they like refine the image even further. Think of it like cleaning up the edges of the player icons, filling in any little gaps, stuff like that, making sure they're working with the most accurate data possible.
It's digital image surgery.
Pretty much. They used a technique called erosion to like shrink objects and remove stray pixels.
So they're basically making sure every pixel counts. It's amazing how much detail goes into this. But vision is only one piece of the puzzle. How did they get all those other strategic details? The weapons, the economy, all that.
A lot of custom software and a deep, deep understanding of CSGO. They call it miscellaneous round information, but it's basically a whole bunch of data points they tracked. Things like weapon types, the bomb status, the score, the money each team has, player health, even armor levels.
Whoa. They really tracked everything. It's like they created a complete digital profile of the game at that specific moment.
Yeah, capturing every little detail that might influence player decisions.
Okay, so we have all this data, but I'm still trying to wrap my head around those artificial neural networks, those ANNs. How do they actually learn?
Well, you can think of them as a network of interconnected nodes, right? Each node, it's basically a simple math operation, and they're arranged in these layers.
Layers. Okay, this is starting to sound like a layer cake of AI.
Kind of, yeah. And the connections between the nodes, they have different weights, which is how strong the signal is between them.
Okay, so it's not just a bunch of nodes, it's how they're connected that matters.
Exactly. And the really cool part, the ANNs can learn by adjusting those weights.
So they're basically figuring out which connections are more important than others.
You got it. And the more data you feed them, the better they get at making those connections.
So it's like the AI is fine-tuning its understanding of CSGO, figuring out what matters most.
Precisely. And they use a ton of data to train these ANNs. They show it all the game details, and then they show it the actual player positions.
It's like showing someone a bunch of practice problems and the answers.
Exactly. So the ANNs try to figure out, okay, how do I get from these game details to these player positions?
So they're not just memorizing, they're actually learning the patterns. This is blowing my mind. But even with all this training, players can still be unpredictable, right? They don't always do what you'd expect.
That's true. And the researchers knew that. So they did something really clever. They built in what they call probabilistic modeling.
Probabilistic modeling.
Instead of just saying player A will be at this spot, the system gives a range of possibilities, and some are more likely than others.
So it's not saying this is definitely going to happen. It's more like here are the most likely scenarios.
Exactly, like a weather forecast. There's a 70% chance of rain, a 20% chance of clouds, and so on.
So they're acknowledging that you can't perfectly predict human behavior.
Right. There's always an element of uncertainty.
It's a much more realistic approach.
Yeah.
It's like the AI is saying, I'm pretty sure this is what's going to happen, but hey, players are human. They might throw a curveball.
Exactly. Yeah. And that makes the whole thing even more impressive, doesn't it?
Totally. Okay, I think I'm starting to grasp how all these pieces fit together. It's pretty amazing. But let's go back to the beginning. I'm really curious about how they turned raw gameplay footage into something the AI could understand.
It's like translating from the language of video games to the language of data. And they used a whole bunch of clever tricks to do it.
Okay, take it from the top. I'm ready for the deep dive into data transformation.
All right, buckle up. We're going deep into the world of image processing. All right, buckle up. We're going deep into the world of image processing.
I'm ready. Let's do it.
So remember, the goal was to extract those player position stencils, right?
The snapshots.
Yeah, exactly. Those snapshots in the minimap at, that very specific time. But raw video, it's just a mess of pixels to a computer.
Right. It doesn't just magically understand what it's seeing.
So they had to apply all these image processing steps, things like background removal, pattern matching.
We talked about that a bit earlier, right?
Yeah. They had to program the system to find the players on the minimap.
Pick them out from all the background stuff.
Exactly. And then record those positions at that 1 minute 45-second mark.
So they essentially taught a computer how to watch a CS:GO match.
In a way, yeah.
That's incredible. Like, it can actually understand what's happening in the game.
It's really mind-blowing when you think about it. That's the power of machine vision, right?
Yeah.
It's giving computers this whole new way to see and understand the world around them.
And this is just for esports, right? Imagine what this could do in other fields.
Oh, absolutely. It's going to be huge for anything that uses visual data.
Like self-driving cars, medical imaging. The possibilities are endless.
Totally. But for now, let's stick with CSGO. We still need to unpack those image processing techniques a bit more.
Okay, back to the game. Let's get into the nitty-gritty. I want to know the secrets.
All right, so one of the key techniques they used is something called color thresholding.
Color thresholding. Sounds kind of technical.
It is, but it's not as complicated as it sounds. It's basically a way to isolate certain colors in an image, which was essential for separating the players from the minimap background.
Okay, so imagine the mini-map, right? You have the map itself, which is probably all sorts of colors, right?
Yeah, for the terrain, the buildings, all that.
And then you have the players who are probably represented by colored dots or icons or something.
Exactly. So with color thresholding, you can create a filter that only lets through pixels in a certain color range.
So they could set it up to only show the colors of the player icons and everything else just disappears.
That's pretty much how it works, yeah.
It's like a digital sieve.
A digital sieve, I like that.
Yeah.
It's filtering out everything except what you want to see. And once they've isolated the player pixels, they can, figure out their positions on the mini-map.
Makes sense. But did they have to do this for every single map in CSGO? Because, the maps all look different, right?
They do.
Mm.
And the colors can be slightly different depending on the map, too. Like the lighting might be different or the overall style of the map.
So even small changes in color could mess things up.
Exactly. So, yeah, they had to calibrate the color ranges for each map, make sure they were getting it right.
So it's not just a one-size-fits-all thing. They had to really fine-tune it. That's pretty meticulous.
It was. But that's how they got such accurate results.
Mm.
And color thresholding was just one piece of the puzzle. They also used what are called morphological operations.
Morphological operations. Okay, now that sounds complicated.
It sounds intimidating, I know.
Yeah.
But it's basically just a fancy way of saying manipulating the shapes in the image.
Okay, so smoothing out rough edges or
Yeah, exactly. Or filling in little gaps or isolating shapes based on their size.
It's like they're cleaning up the image, making it perfect for analysis.
Exactly. They had to be super precise, right? Because those mini-maps are pretty small, even a few pixels off, and the data is no good.
Makes sense. So what's an example of a morphological operation?
Well, one they used a lot was called erosion. It basically shrinks the size of objects in the image.
Shrinking. Why would they want to do that?
Well, sometimes, after they've isolated the player pixels with color thresholding,
Right.
there might be some stray pixels hanging around that don't actually belong to the player icon.
Like little bits of color noise.
Exactly.
Yeah.
Erosion helps get rid of those, cleans up the edges, make sure they're only looking at the real shape of the player icon.
So it's like they're refining the outlines of the players, making the data super accurate.
Yep. And they used a whole bunch of different morphological operations too, like dilation, which is the opposite of erosion. It expands objects instead of shrinking them.
Okay.
And then there's opening and closing, which are combinations of erosion and dilation. They use those to remove noise and smooth things out even more.
So they have a whole toolkit of image manipulation techniques. It's like digital plastic surgery for those mini maps.
That's a great way to put it. And after all that, they can actually pinpoint the exact location of each player on the mini-map using, just basic geometry.
So it's like they've turned visual patterns into numbers, data that the AI can actually work with.
Exactly. That's the bridge between machine vision and AI. It's how you go from those raw pixels to, the structured information that an AI can learn from.
It's like translating from the language of video games to the language of AI. It's incredible.
It really is. And it's a testament to how creative and resourceful these researchers were. They had to combine so many different fields, computer vision, image processing, game mechanics, all to create this system that could, like, capture the essence of CSGO strategy.
It's like a perfect blend of tech and gaming knowledge. But how did they know they were capturing the right information? Like, there's so much going on in a CSGO match. How'd they decide what to focus on?
That's a great question. And that's where their expertise in CSGO really came in. They had to think like professional players, figure out what factors were most likely to influence, the decisions those players would make.
So they had to put on their analyst hats and really get inside the heads of the player?
Exactly. And they came up with a list of key variables to track. Things like,
Okay, let me guess. Weapon types. I bet those were important.
you got it. Knowing what weapons each player had was crucial, to understand their strengths and weaknesses.
What about grenades? Those can be game changers.
Oh, yeah, definitely. They tracked which grenades each player had and whether they used them.
Okay, I'm on a roll here. What about the bomb? They had to track that, right?
Absolutely. The bomb status was a huge factor in player movement.
It's like we're piecing together a CSGO puzzle.
We are. And those are just a few of the variables they tracked. They also looked at things like
Yeah.
the current score in the match.
Right, because if a team is losing, they might play more aggressively.
Exactly. And then the amount of money each team had.
Ah, the in-game economy.
Yeah, that determines what weapons and equipment they can buy.
So it ties into everything else.
It does. And of course, they tracked whether each player was alive or dead.
Well, that's kind of important.
Right. You had to know who's actually in the game. And they even went a step further. They tracked things like player health and armor levels.
Whoa. It's like they created this digital fingerprint of the entire match.
They did. And that's what allowed their AI to be so accurate. It was working with this incredibly detailed picture of the game.
It's amazing to think that a computer can understand something that was designed for humans to play.
It is. But, even the best analysts get things wrong sometimes.
Yeah.
Humans are unpredictable, right?
Yeah.
So did the researchers account for that? Like, how did they deal with the randomness of human behavior?
That's a great point. And it's something they definitely thought about. They knew that they couldn't just create an AI that makes, like, perfect predictions. Right, because sometimes players just do unexpected things. They take risks, they make mistakes.
Exactly. So they built in what's called probabilistic modeling.
Probabilistic modeling, that sounds kind of familiar.
Well, remember how we talked about the weather forecast analogy?
Yeah, like 70% chance of rain.
Exactly. So instead of saying, player A will definitely be at location X,
Right.
their system actually predicts the probability of a player being at different locations.
So it's like a range of possibilities.
Exactly. Some locations are more likely than others based on all the data.
It's like the AI is saying, I'm pretty sure this is what will happen, but there's always a chance things could go differently.
Exactly. And that makes the whole thing so much more robust. It acknowledges that you can't always perfectly predict human behavior.
Right, because CSGO is a game of skill and strategy, not just a bunch of data points.
Exactly.
This is so cool. They're using AI, but they're also respecting the human element of the game.
And that's what makes their research so groundbreaking, really. They're not trying to replace human analysts. They're trying to give them new tools.
To see the game in a whole new way.
Exactly. It's like they've given us a new lens to look through.
This is just the beginning, though, isn't it? I can imagine this getting even more sophisticated. Like, what if they could analyze player communication or even, like, psychological profiles?
Oh, absolutely. That's what's so exciting about this research. The possibilities are endless. But before we get too carried away, let's take a step back and recap what we've learned. We've talked about machine vision, how they captured those player positions, and how they accounted for, human unpredictability with those probabilities.
Okay, I'm following so far.
So I think it's time we finally tackle the heart of the system, the artificial neural networks, those ANNs. Remember, there would take all that data we've been discussing, all those details, and use it to make those incredibly accurate predictions.
Okay, bring on the ANNs. I'm ready to have my mind blown.
Okay, so ANNs, they're like the brains of the operation, right?
Yeah, but honestly, they still feel kind of mysterious to me. Like, how do they actually learn?
Well, think of them like a simplified version of our brains.
Okay.
They're made up of these interconnected neurons that process information.
I'm picturing like a giant web of connections.
That's a good way to visualize it. And those connections, They have different weights, which basically means some connections are stronger than others.
So some signals are louder than others.
Exactly. And during the training process, the ANN learns by adjusting those weights,
Yeah.
figuring out which connections are most important for making accurate predictions.
So it's like the AI is constantly fine-tuning its understanding of the game.
Exactly. And it does this by analyzing tons and tons of data. Remember how they fed the ANN all those game details and the actual player positions?
Yeah, like it was studying for a big test.
Right. So the ANN is basically trying to figure out, okay, what are the patterns here? How do all these details connect to where the players end up?
It's learning the rules of the game, but on a much deeper level.
Exactly. And the more data it sees, the better it gets at recognizing those patterns.
So it's not just memorizing, it's actually understanding the game. This is
Huh.
wild. But even with all this training, there's got to be some uncertainty, right? Like players don't always follow the script.
They're absolutely right. And the researchers knew that. So they incorporated probabilistic modeling into the system. Remember, we talked about that.
Yeah, like the weather forecast analogy. It's not this will happen, it's there's a chance this will happen.
Exactly. So instead of making definitive predictions, the system assigns probabilities to different outcomes.
So it's acknowledging that the future isn't set in stone. There's always a possibility of something unexpected happening.
Right. Because ultimately, CSGO is a game played by humans,
Yeah.
and human behavior can be unpredictable.
This whole thing is blowing my mind. But I think I'm starting to get it. It's like they've combined cutting-edge AI with a deep understanding of the human element of the game.
That's exactly what they've done. And it's what makes this research so groundbreaking.
So where do we go from here? If we can already predict player positions with 95% accuracy, what's next? Like, could we have AI coaches or AI players that can actually outsmart humans?
Those are great questions. And honestly, the possibilities are pretty mind-boggling. We're still a long way from AI that can truly match human intuition and creativity, especially in a fast-paced game like CSGO.
Yeah, that human element is what makes it so exciting to watch.
Absolutely. But that doesn't mean AI won't have a huge impact on esports. We could see AI systems being used for things like real-time strategy analysis, maybe even personalized training recommendations for players.
That would be amazing. Like, imagine an AI coach that could tell you exactly what you need to work on to improve your game.
Exactly. Or AI that could generate highlights of matches, focusing on those key strategic moments that might be hard for human observers to catch.
This is just the tip of the iceberg, isn't it?
It really is. And as AI technology keeps getting better, who knows what the future holds?
It's exciting and a little bit scary at the same time.
Yeah, it definitely makes you think about the future of gaming and what it means to be a player in a world where AI is becoming more and more prevalent.
I think we need to have some serious conversations about the role of AI in esports. What are the ethical implications? How do we ensure that it enhances the game rather than replacing the human element entirely?
I totally agree. It's a topic that deserves a whole other deep dive. But for now, I think we've covered a lot of ground today. We've explored how researchers combine machine vision and AI to predict player movements in CSGO.
And we've uncovered the incredible complexity of these systems. It's amazing what humans can achieve when they combine their ingenuity with the power of technology.
It's a testament to human curiosity, our desire to understand the world around us and to push the boundaries of what's possible.
It's been an incredible journey, and I'm honestly still processing everything we've learned.
Me too. But I think the biggest takeaway is that AI is already having a profound impact on our world in ways we might not even realize.
And as it continues to evolve, who knows what the future holds? It's an exciting time to be alive.
It absolutely is.
Well, that's all the time we have for today. Thanks for joining us for this deep dive into the world of esports strategy prediction.
Thanks for having me. It's been a blast.
And to all our listeners out there, keep exploring, keep questioning, and always keep diving deep.